So this is about as hard as I can think of making it for the basic solve for x with a trig equation kind of problem. Um, so let's see how we would go about solving this one here. Remember that the name of the game for solving trig equations, basic or not, that you want to get it into the form of a single trig function is equal to a value, and hopefully, preferably, that value is one from the exact values table, one that you can remember. So we've got an expression here which defies all those rules, doesn't it? It's got both sine and cos in it, but it's also got a plus in here, so sine plus cos. So it definitely is nothing like what we have seen. So what can we do about it? Well, this is where it might be worth pausing the video and having a think about it. And I guess the key question here is, if we have to get this into a single trig function, if we have to merge this together in some way, what properties or identities do we have that allow us to convert sine and cos into a single trig function? Pause the video and have a think about it. Okay, you either paused the video or you didn't. And look, there's a couple of things we could do. For example, we've got the complementary angles relationship where I can convert sine into a cos, or I can convert cos into a sine. But in both of those cases, it's not really going to help us, because then we would have something like pi on 2 minus x, or pi on 2 minus x here. So then we wouldn't have the same argument, the value that I'm putting into sine or cosine, and therefore it would be no good. There's not much we could do with it. And even if that wasn't a problem, it wasn't the case, we would still have an addition here that we would have to deal with. Now, the other one, which will prove to be more fruitful, is the trig identity, which is tan is equal to sine on cos. This is the identity that will work. Now, I wonder if you can see where to go with it. Again, pause the video. Now that I've given you the key that it's tan equals sine on cos, pause the video and see if you can figure out how you might be able to change this equation so that you have a sine over a cos. Okay, maybe you got there, maybe you didn't, but here's how you would do it. First of all, I'm going to subtract root 3 cos x from both sides. So that will leave me with 3 sine of x on one side is equal to, I'm going to break my rule here of having equal signs underneath each other for a sec, is equal to root 3 cosine of x. Okay, that's just minus root 3 cosine of x. So all of that is I've subtracted this second term from both sides. Now I'm going to divide both sides by cos of x. Can you see what that's going to do? On the left-hand side, I'm going to have 3 sine of x over cos of x. On the right-hand side, I'm just going to be left with minus root 3. Then I'm going to divide both sides by 3. So I've got sine of x over cos of x is equal to negative root 3 on 3. And then the sine of x over the cos of x is equal to the tan of x equals negative root 3 on 3. Fantastic. So we've now got it as a trig function on the left with nothing out here, and we've got a value on the right, which we will hopefully be able to recognize from our trig table. If we can't, trig information table, information sheet trig table. If we can't, then we might be able to generate a triangle really quickly. So my way of doing it is it's either going to be a isosceles triangle, which gives me 1, 1, and root 2 as my 3 sides, and these would be pi on 4 on both sides. That's how we get the pi on 4 values. Or we've got half equilateral triangle, so side length 2 here, side length 1 here, and this would be root 3 here. Equilateral triangles have 60 degrees, or pi on 3 here, and there's pi on 6 here. So we can see that for tan, we're going to have opposite over adjacent will give us 1 on root 3, which is the same as root 3 on 3 once we rationalize the denominator. So, of course, you can just read your table, but personally, I tend to just draw these triangles out because once you do these really quickly, it's actually faster than looking it up on a table, in my opinion. Anyway, that's just a side point. So what we do then is, as usual, is we consider tan of x hat, the acute angle x hat, which doesn't take the sign on, root 3 on 3. So it's not plus or minus, it's just root 3 on 3. And then we can conclude that x hat is equal to pi on 6. So now we have our acute angle that is going to be added or taken away from the x-axis. Now we need to consider, that's the hard work done. All that's the hard work. The rest of it is like the easier ones, really. Now we just need to consider the domain, which is from minus pi to pi. And as I said in the previous video, it's best if we split that up. So I'm going to go for 0, x, pi. So that's my positive spins first. That means I'm going to go from here to here. Okay, so from 0 to pi, which means I'm not going to touch this. So again, all I'm doing is I'm splitting my domain up to first of all consider, if I split that in the middle there, that'll be from 0 to pi, and then I'm going to consider from 0 to negative pi. Just going to consider them separately because it keeps my thinking in order. So from 0 to pi, the only place we're going to be able to end up with a negative root 3 on 3 is in quadrant 2. Okay, so that'll be quadrant 2. And it's going to be something like this with pi on 6 here. So that's 1. And then, I mean, me talking it through is quite tedious, really. It's quite fast to do in reality. And the other one is looking at the negative spin. So that's negative pi, between negative pi and 0. So same unit circle axes. We're going from 0 in this case because it's the negative direction. We're going backwards this way. So from 0 to negative pi. So there's negative pi there, which means we don't touch this area. So I'm going to shade it out to say I'm not going there. And then I've got these two quadrants left. And which quadrant will we find negative root 3 on 3? Well, this one is positive tan here. So it's only going to be this particular quadrant. And then I'm going to draw in my unit line again and say the pi on 6 is there. Remember, it's always taken from the x-axis, never from the y-axis per se. Okay, so there's my two values, and now I just need to work them out. So for the first one here, I might even just go down straight underneath it so that we can sort of see what's happening here. So with this left-hand side here, our positive spin, we can say therefore x is equal to pi minus pi on 6. So pi minus pi on 6, which is equal to, well, again, do it in your head. We've got pi minus pi on 6. So 1 pi is the same as 6 pi on 6. So that's 6 minus 1, which is 5 pi on 6. That's one solution. And the other one, just got to be careful. We're going backwards here. We're going from 0 backwards to minus pi on, backwards pi on 6. So it's going to be minus pi on 6. So we've got two solutions, which kind of makes sense. We can see those two solutions quite clearly, and one of them is 5 pi on 6 and the other one is minus pi on 6, and we are done.